Good morning, everybody. Thank you for coming on out. My name is Patrick, and I will be talking about Perl 6 on, it's supposed to be Perl 6 on the JVM, but it could be Perl on the JVM, and so on. And to kind of give a little bit of the history about Perl on the JVM, where it stands now, where we would like to see it go. Okay, so this did not work. Because I'm not active. Got it. There we go. All right, so we'll start from the beginning of Perl 6 on the JVM. For me, putting Perl on JVM was always kind of a thought because we have Parrot, and we'd been doing Perl 6 on Parrot sorts of things. And so it's always something that was kind of thought about, but it was never really serious until summer of 2009 at YAPC 10 in Pittsburgh. At the end of the conference, and we had a Parrot workshop at that conference and a variety of other things. And at the end of the conference, I happened to be on the bus going to the airport, and where's my... Oh, yes. Okay, so it ran on Parrot. Recrudo, as it existed in 2009, it would run on the Parrot grammar engine. It's written in Peer, which is the Parrot intermediate representation. We had this thing called the Parrot Compiler Toolkit, an early form of not quite Perl, which you've heard a lot about, so I'm going to give a bigger discussion about it today. But we didn't have proto-regexes, and if you don't know what a proto-regex is, that's fine. You don't need to know what it is. None of us knew what it was until 4 years ago either. So, is it 5 now? 5 years now. But it's a new thing that got added, which meant that I would have to go and rewrite the grammar engine for the 4th time. So as I was on the bus, I happened to be writing, I was joined by Jesse Vincent, Oprah, and he was, at the time, or he had just finished being what was called the Perl 6 project manager. And so we're writing on the bus together, and he says to me, he gives me a couple of observations that he had made that he thought I should know as the Perl 6 guy. He said, all of the major scripting languages now have implementations on JVM and .NET except for Perl. And he said, that's not exactly a good situation for us as a community to be in, that we're all there. And then he went one step further. He said, the only real way that we will ever get Perl onto the JVM or onto .NET is through Perl 6. He didn't see that it was feasible or likely to happen on Perl 5. So his underlying message to me was, it's on you to get us onto the JVM if it's going to happen, or onto .NET, or anything like that. And that was pretty profound for me. I hadn't taken it quite to that level of thinking yet. And I said, well, okay, so somebody's got to write Perl 6 for the JVM. So who's going to do that? So we thought about some more. There's some other things that come along, and you'll see kind of the evolution of the thinking to get to that. But Perl has long had a tradition of run everywhere. You know, you could get Perl running on VMS. You could get Perl running on lots and lots of different platforms. I believe it even ran on Unis, correct? Yeah. And so it has this tradition, but our modern day, you know, we used to always think of a platform as being an operating system, you know, Linux, HPUX, Windows, DOS, those kind of things. But nowadays our platforms are just as easily virtual machines as they are operating systems. For many devices, the virtual machine is the operating system. And of course, if you don't have Perl running on those other virtual machine environments, then you're starting to miss large sections of the computing and information community that could be benefiting from Perl. And so it doesn't reach those, and so, you know, this is a way to try and get to that. Later in 2009, we initiated the Recrudo Star effort. So Recrudo Star was to be a distribution of Perl 6, you know, something that would start to be moving beyond just we're trying to make it work to it's something that people could actually use. In 2009, that meant rewriting the grammar engine so that it would support proto-regexes, and a lot of other pieces had to be done. In the process in 2009, we combined the grammar engine and NQP into NQPRX. So the piece of the story that's here is, as I mentioned, this was going to be about the 3rd or 4th rewrite of the grammar engine that I had done. You know, they have often these things that say, have you written a regular expression engine? And I've written several now. And usually what would happen is I'd write in a regular expression engine, we'd start using it, and then we'd discover there's something about the language we don't like, and so we need to add some new feature into that engine to make it work, which basically meant rewriting it at the core. So in late 2009, I was tired of doing this, and so I said, well, what's the way that I can get so that when I write this regular expression engine, it will become the standard? And the answer was, well, rewrite it in Perl 6 instead of in Peer. And then I said, oh, well, then I'll just rewrite it in NQP, which I'm going to explain here in a little bit. But the evolution became that NQP was going to be more than just a language for writing the compiler portion. It was actually going to be the language for writing the regular expression engine. And that worked out pretty well. So let's talk about what NQP is, because before you can talk about Rakudo or Perl on the JVM for the work that we're doing, we have to talk about what NQP is. So it stands for Not Quite Perl. And we'll look at how it evolved. So first of all, we have some Perl 6 code. And we want to be able to run it on something like Parrot, or virtual machine. And this is, of course, where it evolved from. That's a long distance. Wait, I thought there was a laser on here. There is one. That's not it. That's not it. We want to get, there's a long distance between Perl 6 and Parrot. And since Parrot's primary programming language was Peer, trying to get from Perl 6 to Parrot through Peer, we discovered just wasn't going to work. So there's that long distance. Now, of course, Parrot's goal as a virtual machine, or one of its goals, was to be able to run many, many different languages. So not just Perl 6, but also TCL, Perl 5, Python, Ruby, and all sorts of that. And what we discovered is going through the process is that all of these languages have essentially the same steps, or the same sorts of pieces that they need to build. And they all are having to make this long jump between their language specification and the other. So they all needed a parser of some sort. They needed an abstract syntax tree representation. They needed to do code generation, and they would need some sort of object system underneath that was usable. So instead of having them all use that one jump, the goal of NQP was to be something that would sit in the middle, that would provide a higher level abstraction for compiler writers to be able to work. And so this is where Rakudo came into play, is that instead of trying to go straight to Parrot, we now go to this intermediate representation, this abstraction level called NQP. And what NQP has evolved into is that where it used to be just kind of a syntactic sugar for Parrot subroutines, it's now its own virtual machine environment. It provides, when you write an NQP program, it's a virtual machine environment and a language that gives you parsers, it gives you Perl 6 grammars, it gives you an abstract syntax tree representation, it gives you an object meta model, it gives you the ability to do code generation. And so this is where Rakudo essentially sits today, is that it compiles down to NQP, and then NQP has the tools in it to be able to code gen the rest of the way to Parrot. But once we're able to do that, and one of the, here's the key features. You know, NQP is written using Perl 6 syntax because Perl 6 syntax is the greatest syntax known to any of us. Small runtime footprint, few or no built-in functions. It's really designed to be a minimal language, just what you need in order to get a larger thing running on top of it. It has an object meta model system. It has a regular expression engine, has an abstract syntax tree, which we call cast. If you want to know where that comes from, to me, the Q is the big character in NQP. So it's quite an abstract syntax tree. It has some base classes. If you're writing a compiler, there's some base classes so that somebody writing a compiler won't have to start from scratch. It has the ability to natively call into C when you're running on Parrot. And a key feature for this discussion is that it is self-hosted, that the majority of the NQP system is written using NQP. And that has some really important characteristics. So as we go back to this picture, you can see that NQP has self-hosting. And what that means is that since most of the source is written already in NQP, if you change the code gen part of NQP, you can use it to compile to another backend, such as the JVM. So that instead of outputting Peer, the Parrot intermediate representation, it now outputs Java classes. And then if you can get the meta object protocol, if you can get an object system running on the JVM, how hard was that, Jonathan?
Not too bad.
The order of months, years, weeks, Days. Oh my gosh. Order of days. It's pretty nice because Java kind of has an object system already built in, so you get a lot of things in there. So if you can get that going, then all of a sudden NQP is running on the JVM, and those things that depend on NQP or that use NQP to build them will also run on the JVM. Of course, we don't plan to stop there. We can go to the CLR. There is a Google Summer of Code grant or project that will be adding a backend to go from NQP to JavaScript, so that we would eventually be able to run Perl 6 on JavaScript if everything works out. Don't know yet, but it's a good project. It has good chances of succeeding. So this is how we can get to a multi-backend strategy. Now, looking at NQP and what the goals for NQP are, we also want to be able to go back to some of the original idea of being able to run all of these languages as well. That if you wrote your compiler, your language translator, in the NQP system, and if the NQP is good enough to do Perl 6, it ought to be good enough to do some other languages, then you would be able to write a compiler once that would run on NQP and then would be available to run on the JVM, on Parrot, on CLR, and possibly even interoperate with other languages running on that particular system. So that's kind of the vision of where NQP is trying to go. Any questions so far? I'll stop for questions at different places. Jim?
So that would suggest that NQP would take over the role long thought of as being Garrett's target, namely being a virtual machine aimed at all dynamic programming languages.
Yes. In a word, in 2009, 2010, as I was trying to think of how can I make sure that Rakudo remains relevant and stuff, and I mean, essentially it came down to somebody's going to put Perl 6 on the JVM. I don't want to write another compiler from scratch, right? And I don't want I want Rakudo to be that compiler that can be on the JVM. And so it's like, okay, well, this kind of just elevates exactly NQP to that. And then I had another question here.
Yeah, maybe you can mention this at the end or in your presentation. Just, when I go to perl6.org and I look at the feature list of the different implementations, is the JVM implementation going to end up on this list somehow, sometime?
Probably. Probably.
Yeah, nobody's quite maintaining that site as well as it ought to be with the recent announcement.
Yeah, and when I throughout this presentation, I should note that much of this work has occurred within the last 2 months. Right. And if you go, and when I'm talking about Perl 6, of course, NQP is not all of Perl 6. It's a really minimal subset. Rakudo, which is the fuller Perl 6, just barely runs on the JVM at this point. Or maybe it's more than just barely, but not much more. But as you'll see later in the talk, there'll be more. But yes, I believe there should be another column there that distinguishes Rakudo running on Parrot from Rakudo running on JVM. And then I had one from Bruce, and then I'll get JT. Yes?
Where more VM is in that time?
It's down here at the bottom. More VM would be where these dots are. More VM, for those who hadn't heard, is a new virtual machine whose single target is NQP. It's a virtual machine that takes what we had from NQP and says, I'm going to implement that efficiently. JT, you had a question?
Is there any reason, other than until the JVM, CLR, and these others get up to speed, is there any reason to continue the development of Parrot? Does it still have a place?
So the question is, does Parrot still have a place in this? It does for us. In this particular way, if we decided that we needed to experiment with a feature that is not natively available in the JVM or the CLR, that we wanted to try some new things, we'd never be able to get those into those virtual machines. Parrot's an open virtual machine. We can make modifications. We can try things more easily at the virtual machine level. As more VM becomes available, then that may be less relevant. It may be that we can then try them in more VM. And I'll come back to that point a little bit more. And then I had another question here, yes?
One of the things is like, when you talk about the JVM or the CLR, those runtimes have support for some things like threading and asynchronous and so forth, that at least for whatever future maker can see that Rakudo with the current version tends to lengthy mine.
Right. So the question was the comment was about threading being available already in these other platforms that aren't available in Parrot, and I have a slide on that in a little bit. So we'll get to there. Okay, so a little bit about NQP compiler basics. There are a variety of pieces that we use to create a compiler in NQP. So we have a grammar for parsing the source code. It's a Perl 6 grammar, so you get Perl 6 regular expressions, rules, and all of those things. Attached to the grammar are a set of actions. And the actions are the things that are done as the parse is taking place. If you had like traditional compiler courses then, or at least when I went and did a compiler course in college, they always talk about you create a parse tree and then you traverse the parse tree to produce the semantic tree and then you go and use that to do code gen. You can't do that in Perl. In Perl, while you're parsing, you're doing stuff. You're actually executing things. Things happen at compile time. Things happen at parse time when you're dealing with Perl. So the actions are part of the parse. If you've ever watched Rakudo compile, and it prints out the stages as it's compiling like the setting, then you'll notice the parse stage takes forever, but the abstract syntax tree stage takes 0 seconds, and you might wonder why is that? And the answer is because it did all the abstract syntax tree part as it was parsing. So that's it doesn't fit into those phases really well. The result that we expect 2 results from doing the actions. One of them is the abstract syntax tree, and that's just a tree of nodes representing the operations to be performed. But we also have this thing that's called the world, and the world is the already compiled pieces that the compiler did in the process of doing the parse and the compilation and building the abstract syntax tree. Again, we have begin blocks. We have things that happen at parse time that compile into executable code, and we've got to keep that around somewhere. So there's a serialization format, and that's what the world does. Once you have all of that, then you can take the abstract syntax tree nodes and you can generate low-level machine code. So this is actually put into 2 parts. We talk in the NQP world about the front-end compiler and the back-end compiler. And going back to my previous slide, if I can get there, right? So as far as NQP is concerned, the front-end compiler is the part that takes all of the languages at the top and gets them down to the cogen, and then the back-end is the part that gets it from the AST and those parts to your specific virtual machine environment. So a lot of the work that was done on NQP, I helped prototype, spec out, and things like that. Much of the rest of this talk is me usurping Jonathan's work for a talk. We'll just kind of identify some of the pieces here that Jonathan's done. So Jonathan, of course, likes to tell the story, so I'll repeat it, that he got started in all of this with junctions way back in, what, 2007? And it started with junctions. Yeah, exactly. So it started with junctions, and he discovered that, if you really want to do junctions correctly, you need to have multi-dispatch. So he wrote the multi-dispatcher for Perl 6. And then discovered, well, if you need to do that, you're really going to have an meta-object protocol to be able to do the dispatch correctly. So he ended up writing 6 model in order to be able to support that. But in order to do the pre-compilation correctly and get all of the meta-object protocol stuff, you have to have serialization and initialization. So he ended up doing that as part of NQP. That led directly to NQP JVM, which is kind of what I'm talking about today. Of course, that led to MoreVM, which was announced this last week, or revealed this last week, which is a virtual machine specifically designed for that. And along the way, Jonathan also did a Rakudo debugger, a grammar debugger, Zavalai, and Blitzcots. So So I'm talking today about this piece, which encompasses a lot of the other pieces as well.
How much he wasn't a slacker.
I know. So let's look at Perl 6 as it's implemented by Rakudo. Okay, internally, the compiler has these parts, which I described in text before, but we're going to kind of give it graphically. And this is going to show what's involved in creating this NQP multi-virtual machine environment. So along the bottom of this, there's a graph that has the different parts. So in Rakudo, The compiler itself consists of these 5 things. There's a grammar that is a Perl 6 grammar, the thing that we need for parsing Perl 6. There are the actions, the part that take the parsing and convert it into the abstract syntax tree and the world components. There's the world itself, which is the things that were compiled and serialized at compile time. There's a set of meta objects that are the objects that define Rakudo's object system. Whenever Perl 6 is running. And then there's a thing that's called a core setting. And the core setting is all the built-in functions that Perl 6 programmers would typically use. So that's things like push and pop and, give me the number of elements and strings and so forth like that. All of those are written in Perl 6. Now, the core setting is written in pure Perl 6. In other words, Rakudo actually compiles its own setting. When the core setting is compiled, it is a full Perl 6 compiler with traits and those kinds of things that are there. The ones that are in the light green are NQP's version of Perl 6. So somebody looking at the code would instantly say, oh, that's Perl 6 code, or they would say, oh, that's line noise if they really hated it. But they would look at it and it's instantly recognizable as being Perl 6 code, but it's a minimal form of it. There are some things that aren't available to you when you do that.
Assignment.
Like assignment. You can't do assignment. It only has binding. There's no list operators in NQP. You always have to put your parens in place. But you do have method calls. You do have the ability to do regular expression matches, things like that. Okay, so that's what Rakudo looks like. NQP looks much the same, but the only difference being that its core setting, of course, is written in NQP. And so we have an NQP compiler that is written almost entirely in NQP. That's what it means to be self-hosted there. And so you use that NQP compiler to build up all of the light green parts of Rakudo. And then you use the parts that you get after doing the light green parts of Rakudo to compile the core setting, and you have your Perl 6 installation ready to go. So what is NQP's abstraction layer? What is it that NQP provides to compiler writers? Well, first of all, it provides cast, a common abstract syntax tree that it expects to be able to compile. It provides 6 model, which is a meta object protocol. It's a meta object system, so you can build up your object system for whatever language you need. And it provides a set of what we call NQP ops. They're primitives. They're the primitives that are available to a language author, such as Perl 6 or whatever. They're primitives that are available to that to be able to build up your functions in whatever you need to do. And so there's this nice abstraction layer that's there. There are currently about 470 NQP ops. And those include things like add to integers, add to floating point numbers, concatenate strings. Some of them are very, very simple. Some of them are a little bit bigger, such as do a method call on something, look up a method, push something into an aggregate structure, pop something from an aggregate structure, and so forth. Now here we see this new color come in. When you're wanting to take NQP and put it on a new backend, such as the JVM, the pink parts are the part that you're going to have to write. Okay? So you have to write an implementation of 6 model for whatever your backend is. As we heard from Jonathan, for somebody with Jonathan's superhuman capabilities, it takes on the order of days to do that. But he's not the only person who will be doing that, because we have other people porting to other ones to be able to do that. And you need to be able to provide the NQP ops, but those are actually pretty straightforward. That's not too hard to do. So then we have the VM specific parts. This is the back-end part that's there. And so on the back end, you would want to, or you would need to write the thing that would convert from the abstract syntax tree to whatever representation your virtual machine wants to have. For Parrot, it's called PEERT, which is pure text. I think that's what it stands for, or translation, or pure tree, because it's a tree form of pure, right? And then you would run it on your virtual machine. So for the Java virtual machine, it's called JAST. Is that right? Yep. Okay, so it's called JAST. What is it? I hadn't actually looked at. I hadn't actually seen JAST output. Is it text or is it a tree?
It's a tree.
It's a tree. And then does it go straight to .class or does it go through a text form?
It has a completely
readable text format that it gets down to.
Okay.
Which an 800-line Java program that I hate reads in.
Okay.
We'll get rid of that intermediate text stage.
Okay. And then would be able to do run on the JVM, and as other backends come up, then we would be able to do those as well. So why pick the JVM of all of the other ones? All right. So of course the first one, the one that Obra kind of challenged me with, or mentioned to me way back in 2009, to bring Perl to the JVM world, to actually have Perl exist on JVM. Another reason for choosing JVM is that it's already in a highly optimized, established virtual machine, unlike Parrot, which is what we had been working with. Parrot needs a lot more optimizations. It needs a lot more maturity to be able to run Recrudo well. And often it's nice if you have a known target that is not likely to change very much. And JVM represents one of those possible targets for us. So it also means that you start to put a constraint in. I think in retrospect, one of the problems we perhaps had is that we had a little too much freedom to move things around. And sometimes you're able to progress best when you have some constraints that you have to work with and figure out how to solve problems with them. But because Parrot meant that we kind of had a blank slate if we needed to add stuff, then there were a lot of questions of, well, where will you put this? With the JVM, if we want to change something in the JVM, it's not likely to happen anytime soon. So we know where we have to put things. And so some decisions become easier for you. Performance is a possible benefit of using the JVM, and I have the question mark there because we don't know exactly what the performance will look like yet. We have some preliminary results, but that might be another reason to do it. And then, of course, in bringing Perl to the JVM world, there are some organizations, some shops that only will want to deal with the JVM. You can use any platform that you want, any language you want, as long as it's on the JVM. And so this is another reason that we could look at using the JVM. There's more benefits. So as was mentioned earlier from one of the comments from the audience, JVM already has a well-established support for threading. It's well known, it's well understood, it's been studied, it's stable. And one of the areas that is left to be explored in the Perl 6 specification and in the implementations is how do you do threading or threaded operations in an implementation of Perl 6. So we kind of have some ideas, and I have a talk about parallelism in Perl 6 tomorrow, where our traditional answer for parallelism in Perl 6 has been, yeah, we like a lot of ideas, but somebody needs to go out and implement some stuff so we can pick the best ones and put that in the spec. But nobody's been able to actually implement anything. Now we have some opportunities to do that. Interoperability might be an advantage of doing this. We may be able to link existing libraries, Java libraries, and you'd be able to access a Java library from your Perl 6 program. That could be really cool. It might make it available even on other platforms, like Android, of course, is a JVM-based platform, so we could maybe do things with Android and get Perl onto an Android system, which would be really nice. Another benefit of JVM, and this is true for any virtual machine that we do with this, we can better understand the speed performance issues in Recrudo. Right now when we benchmark Recrudo and something takes longer than we think it should, it's hard to know. Is that because of the way the programmer wrote it? Is it because of the way Recrudo's compiling it? Is it because of the way Parrot's executing it? Or what Parrot's doing with it? It's really, really hard, and it's real easy to finger point from one group to another to be able to do that. Now, if we have another virtual machine, we can say, for example, it runs slow on Parrot, but it's running fast on the JVM. That tends to point a finger, or point that the culprit might be in Parrot. Or if it runs slow on the JVM and on Parrot, slower than what we expect, then we can say, well, it's probably somewhere up the stack. We're not really thinking about it. So we now have something else to benchmark and test against, which is really useful. Some things that we are not doing, and this also came up in some of the questions, we're not abandoning Recrudo on Parrot. At the moment, Recrudo on Parrot continues to be, and will be for at least the next few months, and possibly longer, the most feature-complete Perl 6 implementation that exists. So we're not going to throw it out. It's still the benchmark by which we have to judge whatever else is done, both in terms of speed, but also in terms of feature completeness. Even if Parrot doesn't have a lot of changes or things coming along, we will continue to support Recrudo on Parrot for the foreseeable future. There were discussions earlier about, once Recrudo becomes available on the JVM, will that become its primary platform for doing stuff? And as the Recrudo Pump King, I'm telling you, we're not declaring a primary platform. There is no official VM for Recrudo Perl 6. Now, that's not a invariant. There might be a day when we say there is a preferred platform or one that will likely be best for you. But there will never be an official, this is the target platform, because that would mean there's only one way to do it, and we don't believe in there's only one way to do it. We're not going to attempt to come up with a Perl 6 that will run every Perl 6 program on every platform you can imagine. To me, that just smacks of lowest common denominatorship. So a common question I get is, well, if somebody writes a Perl module that depends on a Java library, how do you use that module in an implementation of Perl 6 that's not running on Java? And my answer is, well, you don't. And you can come up with a module, if you want, that will figure out what platform you're on and do the right thing. Or you may just say, look, that's not a capability that's there. But that's the way, to me, computing has been for a long time. There are things that I can do in C on a Windows system that I can't do in C on a Linux system, and vice versa. And it's just that that's not something the language really needs to do. If you try and make everything the same everywhere, then nobody has enough. That's effectively what it is. So where do things stand now? NQP is bootstrapped, that is self-hosted on the JVM. What that means is that NQP on the JVM can be used as a cross-compiler to build the other backends. So we can actually build and do all of the things that we need to do with NQP without ever having to touch Parrot if we want to. So you can build NQP without Parrot. The Recrudo on the JVM port has begun. It's been underway for about 2 or 3 months. Not even? Yeah, 2-ish, not very long. So this is you're receiving new details. This is not stuff that we've been working on. Well, we've been working on for a year, but we haven't been coding it all for a year. So the Recrudo and JVM port has begun. It can do some things. The process of doing that, some things from Recrudo on Parrot didn't change very much at all to get them to work on the JVM. The grammar and actions, those have pretty much remained the same. The meta objects remain the same. And that tells us that NQP had about the right abstraction layer for being able to do those things. Some things needed some work. The bootstrap process. The bootstrap is where Recrudo defines its core types, the really basic types like arrays and hashes that it needs, and classes like mu and any and things like that. That needed a little bit more work, but not too bad. And then there's the setting. So the core setting in Recrudo is the part that defines all of the Perl 6 primitive Perl 6 functions that you would want to use. In my other graph earlier, that was the dark green section. It's written in Perl 6 and is compiled by Recrudo itself. It's your outer scope for the user programs, and you really can't run much of Perl 6 without having the setting in place, because you don't have any of your basic methods in place. Your class definitions are missing all their methods for the most part, right? Which means you can't do much testing without having the setting, because the tests are all written in Perl 6. So if you want to know how well your JVM is doing, you have to be able to compile the setting. So how big is the setting? It's 13,000 lines of Perl 6 source. So before you can know if your implementation on JVM is working, you really have to be able to compile the 13,000 lines of source. And they're all in one file. So Jonathan said, I'm just going to do it. So start by parsing. Basically run the Recrudo compiler as it existed on the JVM on the setting. When you get to an error, figure out what that error is and try again. See how far you get. So first time you do it, you might get to what? Line 4. Because you get past the comments at the beginning. Right? So you might get to line 4, and you might go from there. And I stole these from another talk that Jonathan gave on the top. So to get to line 100 took on the order of a week to have that part compile. To get from 100 to 1,000 took another week. To get from 1,000 to 2,000 took a day. And to get from 2000 the rest of the way down took another day. All right? So now the setting compiles. Now that doesn't mean everything works, but at least you're able to get there and start running some tests and start doing some stuff to be able to make that work. Now it's worth noting that compiling the setting, I talked earlier about how when you're compiling, it's not just producing an abstract syntax tree and things like that. In Perl 6, it is actually doing stuff. So it's not just compiling in the traditional sense, because line 137 of the setting has a begin block, which means that as you're compiling the setting, you have to be able to execute some Perl 6 code. So you actually have to be able to call trait mod, the set only star method on that particular trait in order to continue compiling the rest of the setting. So you have to get some pieces working in order to do it. Things that you have to be able to execute as you're compiling a source program, including the setting, is you have to be able to do begin blocks, traits, constants, all sorts of things like that have to go in there. But it's now able to compile the setting. Last report I heard is that it passes Hello World. Possibly more by today. I don't know what happened yesterday, if anybody got farther. I know a lot of people are downloading, compiling, and saying, I can't get it to pass any of the tests, to which we say, yeah, we know. But it is making progress. So what's the performance look like? If you really want to know the performance of NQP on the JVM or Perl 6 on the JVM as it exists today, go to JAFB's Need for Speed talk tomorrow at 11:35. I've seen advanced copies and made comments on it. There's a lot of really useful data in there. Our goal has not been performance as the top goal at the moment. Our goal is make it work and make it fast, but we know where a lot of the pitfalls are from having done things with Parrot in the past. There are new pitfalls now to find, and most of those have been avoided already. Performance NQP on the JVM generally runs between 3 and 20 times faster than NQP running on Parrot for an equivalent program. So we already know we're getting a pretty good speed up there. And again, this is NQP on Parrot represents code that has been looked at and examined and optimized over several years. NQP JVM is something that's only been around for a couple of months to be able to do benchmarking and optimization, and we haven't really done that except when something is really egregiously wrong and we can't stand it. Rakudo running on the JVM feels generally faster than Rakudo on Parrot. We don't have any numbers yet because we're not really running real tests, but compiling things like the setting and doing some basic loops and stuff like that seem to be running anywhere between 2 to 5 times faster on the JVM than they did on Parrot. One downside to the JVM is it has a really slow startup time. It's just incredibly slow. Like from the time, I think on my machine, from the time that I start NQP JVM until it gives me a prompt or starts compiling is on the order of a second. And so it's a really slow startup time. So, one benchmark that you would like to be able to do is to say, well, you've got NQP running on the JVM and on Parrot, how long does it take to run the test suite? And they run about the same period of time because Parrot is fast at startup but slow at execution, and the tests are small. And NQP on the JVM is really fast at executing the test, but it takes a long time to get there. So they're roughly the same, so it's kind of hard to say. I think we'll be able to do some optimizations on NQP startup for the JVM and also on Rakudo, but again, that's kind of, we have to get there first. As I mentioned earlier, having multiple backends really helps to locate the bottlenecks. Where are we going next? First of all, with the announcement of more VM this last week, the reveal, I should say, I decided to adopt a new hat. We have different roles for different people who play in Rakudo Perl 6. So, for example, Carl often is the historian. He likes to do the history of what's been taking place, things like that. My new hat is the one who lowers the expectations. So it's hard at a conference like this, it's hard in a blog post. You go through and say, we have this new machine, we think it'll be faster, and what everybody says is, Christmas! And it's like, no, Christmas is not here yet. All right? Yeah, it's not here yet. For a lot of people, Christmas is not here. It's not, I'm not even going to say it's going to be here this year. There's a lot of stuff that still has to be worked on in order to make this work. Now, it is becoming, Rakudo and Perl 6 are becoming more usable every day. More and more people are using it every day for doing different things. So it is a usable system. But it's, you know, the standard question is that I get is, when will it be finished? And I don't even see the finish line yet. So I'm just, you know, it's not there. And especially for the JVM stuff, it's really new and immature. Yes, Chip, you have a question?
I just wanted to put some perspective. Perl 5 isn't finished.
Yes, exactly. So Chip commented the Perl 5 isn't finished. What I have discovered, and of course this is a somewhat friendly crowd, right, is that somebody will say to me, Perl 6 isn't finished, and I say Perl 5 isn't finished, and they say that's a cop-out. I know, and I don't think so either, but you know, they'll say, oh great, so now we're debating the semantics of finished and everything, and they're like, everybody knows what it means for Perl 6 to be finished, but whenever I ask for a definition, nobody can define it. Or they'll say, well, it's when 1.0 is released. Well, okay, great. You know. I don't want to rehash the whole thing right now. It's bad stuff. All right. So the next steps, short term. So the June 2013 release of Rakudo will have the JVM backend stuff in it. In fact, it merged yesterday. The JVM branches merged into the main trunk yesterday. So the next release will have the JVM backend code in it. That's not to say it will run anything or pass all the tests, but it is part of the main development branch as of now. The next steps, so I have these up there as, these are not things that it does today, these are next steps of things we want to do, is to get it to pass the sanity tests. The sanity tests are the low level, you know, can you even print something to the output, and can you add two numbers together type of thing. And then after getting the sanity tests running, next would be the roast tests. Those are the spec tests, the ones that are the Perl 6 specification definition. And the target for having that running is August 2013, unless it changed, or is that still the case? Yeah, probably, might be. You know, these are fudgy numbers. Please don't hold us to them yet. As we get the spec test going, we have to adapt the Perl 6 and Rakudo ecosystems. A lot of modules that exist in the Perl 6 thing were written assuming Rakudo on Parrot. And now we have to make sure that they still run for Rakudo on JVM. Maybe they use some of the low-level pure stuff that we said not to use unless you absolutely have to. Now we may be reaching the point of discovering where the absolutely have-tos are and go back and fix up NQP and do some stuff to be able to support those better. But to have a Rakudo star, which is a distribution of Perl 6 that runs modules, available, we're targeting September, October this year. That's the current thing. Of course, something could happen that, you know, some big obstacle that we hadn't imagined shows up, but there. And of course, the next steps are always to benchmark the runtime and startup performance, because we know, and part of what's driven all of our work for the past couple of years, is that the biggest obstacle to us to having more people using the system is it's too slow. Whether you want to develop, whether you want to be an application writer, whether you just want to contribute. When it takes 10 or 15 minutes to run the tests, that's just too slow a cycle for a lot of people to work on. So anything we can do to make things faster, we try to do. Any questions? Oh boy, the hands all just went up. Let me start in the back and to the front. So Bruce?
When you release Rakudo Star with JVM, do you intend to be separate tarballs, one for JVM and one for Perl, or one tarball with select?
Okay, so the question is, when we release Rakudo Star, which is normally released as a tarball, will we do it for the JVM or for Parrot, or have one tarball that does both? It's most likely to be one that's both, and you select by a configure option. That's kind of what works best for the Rakudo compiler in terms of making it easier for the developers at the moment. So since we're going to already have that option in configure, I suspect it'll just be to there. Now for the precompiled binaries, like the Windows MSIs, those will probably come out as separate binaries. And I don't know that those will be available immediately at the same time or not. Then I had another question. Let me go to Chip, and then I'll do Jim.
It's pretty clear what NQP is, to me, and it's obviously clear what the JVM is. I'm not real clear on what 6 model is.
Um,
And the only reason I'm asking is for context, because like, what are the boundaries of the project?
right.
Is 6 model a part of Rakudo, or is it a thing that Rakudo needs?
It's a thing that, so the question is, what is 6 model? 6 model is something that Rakudo needs. 6 model is something that NQP needs, even to be able to get NQP running. 6 model is a meta object system for building object systems at its lowest level. It's a meta object protocol. So you can use that to, it also contains a representation component where you can define how you're going to represent your native types and things in your virtual machine environment. So it's a set of definitions, it's a set of things that when you put it all together, and it's very VM specific at the moment for some pieces of it, then you get a meta object system that you can use to build up the rest of your object framework in a VM independent manner after that.
So a follow-up to clarify. If you work 6 model the right way on the JVM, your final result is a class file for the equivalent.
I don't know. I think it's more than that. So the question was, well, it
generates a class file, and then obviously there's more metadata and stuff.
Right. So the question was, if you do it right, then do you end up with a class file? At the end, we end up with class files for everything.
Well, yeah.
So, but yeah. So anyway, Jim, you had a question, and then I think I'm going to be out of time for questions. Yes.
Yes, you briefly touched on the question. You mentioned that there are more and more users of Rakudo Perl 6 every day, and my observation of the problems that we had, like in the parent project, and also from like hearing talks by people like Kirk McCusick of FreeBSD, is that the question of actual users, people, production users of an open source technology, is really critical, not so much because it indicates how good the technology is, but because the presence of users brings in the next generation of volunteers, which are needed in open source projects. So I'm wondering, and this of course is something that a lot of people have tossed in an accusatory way at Perl 6 and at Terra and so forth. And that's a question of, well, who actually is using it, and how does that fit into your plans for the future development of the project?
So to repeat the question is, who are the users of Perl 6? And what are our plans, and how does that feed into our plans for improving the project as a whole and not just the code base? Having done a couple of other open source projects before, and this is not, I don't claim to be an expert on open source projects. All I know is what my experience is. I would create an open source project, I put it out, I was the lone developer for a while, or maybe a couple of friends that I knew, we would work on it, but it was out there and stuff. And then all of a sudden you end up with people coming from out of nowhere to contribute, where they'll say, and they'll say things like, I've been using your product for like 4 months and it works great for me, but if you could add this one little feature, it would be even better. And you discover, much as was said in the keynote yesterday, you kind of have this, you're doing what moment? Like you're actually using my code for something real? No, stop. It's not ready yet, type of thing. And we're starting to see those kinds of things where people are coming in and asking questions and they're saying, I've been using this for some of my projects or things like that, and do that. The things that we have to do, and the things that I think are the most important. Okay, it's trying to tell me my time's up.
I don't like that phrase right now.
Oh, man. The thing that I think that we have to do, the number 2 complaint, without doubt, about, well, there's 2 or 3, but the number 2, the one I would place number 2, without a doubt behind it's too slow, is where's the darn documentation? And what we need is we need to find more people who are users who are willing to write about their experiences or willing to contribute a little bit of documentation, because those are our on-ramps. That are there. A close number 3, or maybe tied with number 2, is to get rid of all the bugs. But that's just a slow process. Beyond that, if there's any other suggestions, meet me in the hallway or afterwards and give me other suggestions. And then Larry.
In fact, we do seem to have a continual supply of new people coming on the project. There's not just the same old people doing all of it.
Yeah, I did a for a blog post I did yesterday. I wanted to go and find out how many committers were there to Perl 6 over the past year. And so I went and looked through the GitHub logs to see how many committers, individuals, there were who had committed to either Rakudo, NQP, the Perl 6 documentation, the Perl 6 website, or the specs, or the standard grammar, those locations. And it was 70. There were 70 committers. And when I tell that to most people in the team, they're like, who are they? Right? We don't know who those 70 are, but there were 70 committers, and that was individuals. I actually went and removed duplicates where you might have one committer under 2 different names or 2 different email addresses. I know I'm out of time. Catch me in the hallway. Thank you very much.